So in the last video on infinite series we have studied comparison test 2, that is called practical comparison test. Comparison test 2 or practical comparison test. What is that? Sigma A and sigma Bn are two positive term series and An by Bn n tends to infinity is L. If L is not equal to 0 and finite, then sigma An and sigma Bn behave alike, and if limit is 0, this limit is 0, then sigma Bn diverges, then sigma An also diverges. Let me verify. Yes, sigma is 0 and sigma Bn converges, then sigma An also converges. And third, if limit is infinity, sigma Bn diverges, then sigma An also diverges. This is practical comparison test. And one more important thing is that is auxiliary series or P series test. What does this say? Sigma 1 upon n raised to p converges if p greater than 1 and if p greater than 1, diverges if p less than or equal to 1. That is P series, and using comparison test and P series we can solve many problems. And take this problem now. Discuss the convergence of the following. First one, sigma 1 to infinity square root of n square plus 1 minus n. Second, 1 plus 1 upon 2 square plus 2 square by 3 cube plus 3 cube by 4 raised to 4 plus so on. Next is sigma 1 to infinity root of n square plus 1 minus root of n square minus 1. Now see the first problem here, we make use of that comparison test. Second comparison test, that is sometimes called practical comparison test, and P series, or it is called auxiliary series. First one, let An is root n square plus 1 minus n. It is root n square plus 1 minus n into root n square plus 1 plus n upon root n square plus 1 plus n, multiply and divide by conjugate of this. It is therefore n square plus 1 minus n square upon square root of n square plus 1 plus n. Therefore it is 1 upon root of n square plus 1 plus n. What is this? An, nth term of the given series. Now we choose Bn as, we apply comparison test here, that is called practical comparison test or second comparison test. Now how do you choose Bn? 1 upon n raised to p, where p is degree of denominator minus numerator. So 1 upon n here. 1 upon n, because what is degree of denominator? 1. N square root is there, therefore highest degree term is n raised to 1 and numerator degree is 0. 1 upon n. Now you have to consider limit an by bn, n tends to infinity. It is therefore, what is limit an upon bn? Upon bn means upon 1 by n becomes into n root n square plus 1 plus n. So it is 1 upon root of 1 plus 1 by n square plus 1 because we take n tends to infinity here, limit n tends to infinity. And what is limit n tends to infinity of this? It is 1 upon 2, because 1 upon n square becomes 0 and 1 upon 2. Now what does comparison test says? It is finite and not 0. Therefore sigma an, sigma bn are alike. Either both converge or both do not converge. But what we know the behavior of this sigma bn. But what about sigma bn? But sigma bn is sigma 1 upon n, whether it converge or diverge. Anybody, it converge or diverge? It diverge because diverges because p is equal to 1 here, and sigma 1 upon n raised to p diverges if p less than or equal to 1. It diverges. Only greater than 1 it converges. Therefore, by this comparison test, sigma an, that is given series, also converges. Given series also diverges. So the given series diverges. So try to practice this one, how to apply comparison test, and also use this p series. You have to, for comparison we take bn, sigma bn as 1 upon sigma 1 upon n raised to p. What is p? P is degree of denominator minus numerator. And if you know this one, you can solve any problem. And one more thing, important thing is you should know the nth term also. What is the nth term of the series? That plays important role here. Say the second term. Nth term is not given here. You have to find out the nth term of the series first. How do you find? Here, an is, nth term is n square, n raised to n. Is it n raised to n upon n plus 1 raised to n plus 1? Am I correct? N raised to n by n plus 1 raised to n plus 1. We generalize here. See numerator, 1 square by 1 square. Correct? 1 square by, you leave the first term here. Leave the first term. In infinite series, we can leave finite number of terms or we can add finite number of terms. It doesn't change the behavior of the series because number of terms are infinite. Finite terms doesn't affect the behavior of the series. So if you leave this one first term, then what happens? 1 by 2 square, 2 square by 3 cube, 3 cube by 4 raised to 4, etc. Therefore, n raised to n by n plus 1 raised to n plus 1. And yes, let bn is, what is bn to be taken? Bn is degree of denominator minus numerator. What is degree of denominator? N plus 1. Numerator n. Therefore, again we take 1 upon n here. 1 upon n. Therefore, what is the next thing? Limit an by bn, n tends to infinity is limit an by bn. Because to apply comparison test, what does comparison test says? If limit an by bn, n tends to infinity is finite and not 0, then the two series behave alike. They are same. Therefore, sigma an upon bn is n raised to n upon n plus 1 raised to n plus 1 into n, because divided by 1 by n is same as into n. It is n raised to n plus 1 upon n plus 1 raised to n plus 1. You write here limit n tends to infinity. So it is limit n tends to infinity, n divided by n plus 1 whole raised to n plus 1, or it is 1 upon 1 plus 1 by n raised to n into 1 upon 1 plus 1 by n. 1 by n. Divide by n now. And this n plus 1 is written as, using theory of indices, n and 1. 1 upon 1 plus n is base. Raised to n plus n is written like this. Now what is the limit? Limit as n tends to infinity of this is, see, 1 upon e it is. Because this limit is e and this becomes 0. This becomes 1. Because 1 upon n tends to infinity is 0 and this is 1. But 1 plus 1 upon n raised to n is e. That we have proved in sequences. 1 plus 1 upon n raised to n converges, series sequence given by 1 plus 1 upon n raised to n converges its limit of that sequence is E. Now conclusion, which is finite and not zero. Finite and not zero. Therefore, sigma an, sigma bn are same. But what about sigma a, bn? Sigma bn is sigma 1 upon n diverges. Why it diverges? Because p is 1. If p greater than 1, then only converges. Less than or equal to 1 diverges. So, the given series diverges. Given series diverges. Now, this problem is similar to the first one. You try this. First, you multiply and divide by the conjugate. What is the conjugate? Root n square plus 1 plus root n square minus 1 and simplify. Answer is it diverges again. That third problem, given series also diverges. Next problem is discuss the convergence of sigma sin 1 upon n and sigma 1 upon n, 1 upon root n, 1 upon root n, tan 1 upon n. Two problems. These two problems are of one type. Discuss the convergence of sigma sin 1 upon n and second problem is 1 upon root n tan 1 upon n. In this case, we use the expansion of sin x and tan x first. And nth term is sin 1 upon n. And we use the series, we write the series using expansion of sin 1 upon n. And for that we use sin x. What is sin x? We know that sin x is infinite series is x minus x cube by 3 factorial, x raised to 5 by 5 factorial minus so on. Therefore, sin 1 upon n is let us take an is sin 1 upon n. Nth term is sin 1 upon n. I write that as an. Sin 1 upon n is 1 upon n minus 1 upon n cube by 3 factorial plus 1 upon n raised to 5 by 5 factorial plus so on. Therefore, it is 1 upon n into 1 minus 1 upon n square by 3 factorial, 1 upon n raised to 4 by 5 factorial and so on. Now, therefore, we choose Bn is, what is Bn? Bn is, it is 1 upon n. Bn is 1 upon n. Because we choose Bn such that limit an by Bn must be some quantity, that is maybe 0, infinity or a finite quantity. Or what is choose Bn? Degree of denominator minus numerator. What is degree of denominator minus numerator? 1. So 1 upon n. Therefore, limit an by bn as n tends to infinity is limit n tends to infinity of 1 minus this an by bn means this 1 upon n cancels. 1 upon n cancels. 1 minus 1 upon n cube by 3 factorial plus 1 upon square, it is 1 upon n raised to 4 by 5 factorial and so on. What is the limit? Limit of this is 1, because this 1 upon n square, 1 upon n raised to 4 all tends to 0. As n tends to infinity, 1 upon n is 0. So the limit is 1, which is finite and not 0. This is finite and not 0. Therefore, which is finite and not 0. Not 0. So what is the comparison test? Therefore, sigma an, sigma bn are alike. Either converge or diverge together. But we know the behavior of the sigma bn. Sigma bn is sigma 1 upon n diverges. Why sigma 1 upon n diverges? Because it is sigma 1 upon n raised to p form and p is equal to 1 sigma, because sigma 1 upon n raised to p diverges if p less than or equal to 1. P is 1 here, therefore diverges. Therefore, given series sigma n is sigma sin 1 upon n diverges. This diverges. See, we have used to write an, we have used expansion of sin. Sin x as infinite series. Next problem is similar, but we have to use tan x expansion. Say next problem, what is that? Convergence of 1 upon root n tan 1 by n. We have tan x is expansion of tan x plus x cube by 3 plus 2 by 15 x raised to 5 2 by 15 x raised to 5 plus so on. This is tan x expansion. Therefore, let an is 1 upon root n tan 1 upon n is equal to 1 upon root n. What is tan 1 upon n? Tan 1 upon n is 1 upon n cube by 3, 2 by 15, 1 upon n raised to 5 plus so on. See, the expansion of tan x is used here. This is the expansion of tan x. Tan 1 upon n, so replace x by 1 upon n. It is 1 upon, I take n root n, 1 plus 1 upon n square by 3 plus 2 by 15, 1 upon n raised to 4 plus so on. Therefore, what is Bn to be taken? Let Bn is 1 upon n raised to 3 by 2. N root n means n raised to 1 plus half, n raised to 3 by 2. Now what is the next step procedure? We apply comparison test. For that we calculate limit an by bn. This is called practical comparison test. Is limit n tends to infinity of an by bn is 1 plus 1 upon n cube by 3, 2 by 15, 1 upon n raised to 4 plus so on, plus infinite terms are there. Limit an by bn, I think you followed, because this cancels an upon bn. What is the limit of this? 1. Because 1 upon n tends to infinity. Sorry, 1 upon n tends to 0 as n tends to infinity. Now see, conclusion. What is the conclusion? What does practical comparison test says? Or comparison test tool says? If limit an by bn is finite and not 0, that is satisfied here, finite and not 0, then sigma an, sigma bn are alike, same. But we know sigma bn. Sigma bn is sigma 1 upon n raised to 3 by 2. It is of the form sigma 1 upon n raised to p, where p greater than 1. Therefore, converges. Why sigma bn converges? Because sigma bn is sigma 1 upon n raised to 3 by 2. P is 3 by 2, it is greater than 1. Therefore, converges. Therefore, sigma an, that is given series converges. I have taken different types of problem here. Sin 1 upon n, 1 upon root n, tan 1 upon n, so on. But the last two problems require some expansion of sin x, tan x. That you have to, you should know. Next problem is discuss the convergence of 1 upon 1, 2, 3, 1 into 2 into 3, it is 3 by 2 into 3 into 4 plus 5 by 3 into 4 into 5 plus so on to infinity. Discuss the convergence of this series. Here it is the given series the terms of the given series are given here. Therefore, nth term you have to find out by generalizing or using any formula. First thing is therefore to find out nth term. To find nth term of this series. How to find? We generalize. See the numerator 1, 3, 5, etc. Numerator is 2n minus 1. Because what is the nth term of 1, 3, 5, etc.? 2n minus 1. Denominator, we have to take separate factors. First factor, 3 factors are there. If we multiply 1, 2, 3, that is 6. It is 24. Then we cannot generalize. So we find out the nth term factor by factor. First factor. What is the first factor? 1, 2, 3, etc. Therefore, nth term is n. Take second factor in the denominator. Second factor 2, 3, 4, etc. Sorry, nth term is n plus 1. Third factor, what is the third factor? 3, 4, 5, etc. Nth term is n plus 2. Therefore, denominator is n into n plus 1 into n plus 2. So here we have to find out the nth term also. First we have obtained that one, nth term. Therefore, let an is 2n minus 1 by n into n plus 1 into n plus 2. So we can say that the problem is quite different here. Here the nth term also we have to obtain. Nth term. How we have obtained? Generalizing. Numerator is 1, 3, 5, therefore 2n minus 1. Denominator 3 factors are there. 1 into 2 into 3. In this second term, denominator 2 into 3 into 4 and so on. That we have taken separate factors. First, second, third and generalizing we have obtained this. Now, next thing is quite usual. You have to apply practical comparison test for this type of problems. Choose Bn as 1 upon n square. Why you have to choose 1 upon n square? Because how to choose Bn? Bn is 1 upon n raised to p, where p is degree of denominator minus numerator. What is degree of denominator? 3. N into n into n cube you will get. Highest degree term as n cube. That is the degree. Numerator degree is 1. Therefore, 3 minus 1, 2. N square. Therefore, limit an upon bn, n tends to infinity, if it is not reached in series and sequences, you have to take that as infinity. Limit, I will write only limit. Limit n tends to infinity of an by bn is limit n tends to infinity of 2n minus 1 upon n into n plus 1 into n plus 2 upon 1 by n square means into n square. Now the convergence or divergence depends on this limit. It is limit n tends to infinity of divide numerator denominator by n cube. You will get 2 minus 1 upon n divided by n cube 1 plus 1 upon n into 1 plus 2 by n divided by n cube numerator denominator. And what is the limit? Always to find the limit as n tends to infinity we use 1 upon n tends to 0 as n tends to infinity. So 2 by 1 into 1 or it is 2. Now the behavior or test depends on this value, which is finite and not zero. Therefore, by comparison test, sigma an, sigma bn are alike. Either both converge or do not converge. That is the comparison test. But sigma bn is sigma 1 upon n square converges. Why it converges? because P series test or auxiliary series. What does P series test says? Sigma 1 upon n raised to P converges if and only if P is greater than 1. P is greater than 1 here, 2 it is. Therefore, given series converges. That is the conclusion. I saw lastly one problem. That is again problem is somewhat different. It is. I left some problem as exercise here. I think you can try all the problems here. Discuss the convergence of sigma cube root of n cube plus 1 minus n and sigma cube root of n plus 1 minus cube root of n. Now in such cases, if it is square root, then we know the rationalizing factor. Easily we can rationalize and we can apply practical comparison test. But in this case, cube root of n cube plus 1 is there, so we use binomial expansion here. 1 plus x raised to n, binomial expansion for any index. N plus x raised to n is 1 plus nx, n into n minus 1 by 2 factorial x square plus n into n minus 1 n minus 2 by 3 factorial x cube plus so on. First we apply this one. Here an is n cube plus 1 raised to 1 by 3 minus n. We write this as e dash n cube into 1 plus 1 upon n cube raised to 1 by 3 minus n. So it is n into 1 plus 1 upon n cube raised to 1 by 3 minus 1. I think followed this one by taking n cube common. It is n into, now we expand this one, 1 plus 1 by 3 into 1 by n cube plus apply this, n is 1 by 3, 1 by 3 into 1 by 3 minus 1 upon 2 factorial into 1 by n cube square plus so on, minus I have taken n common here, n common plus so on infinite term minus 1 followed. Now here n taken common here, n cube raised to 1 by 3 is n and this n common. Now that one cancels, this one cancels, we get an is nth term of the series is, it is 1 by 3 1 by n cube plus 1 by n cube plus 1 by 3 into 1 by 3 minus 1 by 2 factorial into 1 by n cube square plus so on. Is it correct? 1 by 3 into 1 by n cube yes, just a minute, 1 n into 1 plus 1 by 3 1 by n cube 1 by n cube square plus etc. This n common, n is there, yes. Therefore it is, say I write this as this one cancels, but n we have to multiply it. Therefore 1 upon n square, because this 1 n cancels, 1 upon n raised to 5 is not 6 plus so on. Now it is correct? Yes. Therefore it is 1 upon n square into 1 by 3 into 1 by 3 minus 1 by 2 factorial into 1 upon n raised to 3 plus so on. Now therefore an is this. How to choose bn? We choose bn is equal to 1 upon n square now. Bn is 1 upon n square. Therefore, apply comparison test. Limit an upon bn, n tends to infinity is, limit an by bn means this cancels. We get 1 by 3 because this all the next term tends to 0 as n tends to infinity. Now it is finite and not 0. Not 0. Therefore, what is your conclusion? Sigma en, sigma bn are alike. But sigma bn is sigma 1 upon n square converges. Therefore, the given series converges. Sigma 1 upon n square bn, it converges. Why it converges? P greater than 1. Therefore, the given series also converges. Second one exercise. Next different tests are there. I do one by one. In the next period, I consider mostly Cauchy's root test, nth root test. Okay, thank you.